Thank you very much. I will not show you any slides because I want to develop the study with you, either as a new project or a project that are in collaboration with your past lab that you will be leaving to join my group. Then I will do that to foster your career development and also to broaden your knowledge base. And the knowledge base will be hopefully broadened with the experience and expertise brought to you from my lab. So in the Andersen group, here at the BRIC at the University of Copenhagen in Copenhagen, Denmark, we aim to understand the pathogenesis and the molecular complexity of hepatobiliary cancers. And to achieve this, our research is organized into 3 themes: immunogenomics, metabolic rearrangements, and epigenomic remodeling or epitherapeutics. And if any of those themes are interesting to you, then look up our website. We do this within our research portfolio. Within our research portfolio, we utilize omics-based approaches to model disease causality, stratify and characterize patients for advancing diagnostics and prognostic biomarkers and theranostic signatures. To achieve this, my laboratory is structured into 2 intersecting sections: an experimental site, generating data and modeling causality or causal factors, and the bioinformatics section, helping you analyze your data if you're not yet trained in analyzing NGS data yourself. In our studies, we often use integrative and high-dimensional genomic patient-derived data, computational methods, as already mentioned, for deconvoluting complex networks. That could be, for example, gene regulatory networks. We use machine learning quite often in biomarker analysis and are starting to use more in-depth artificial intelligence guided neural networks approaches to establish predictive models of the disease we are in question, cholangiocarcinoma. And we use this with the goal to move our discoveries to the clinic. So most of our collaborators, besides some of the people here today, are clinicians in the network, and also clinicians that are not part of this network. What will the department offer you, and offering me as well at the same time, is access to an NGS platform, a single cell and spatial transcriptomic core facility, a robotic screening facility, as well as, of course, an animal facility and a complex fax facility as well. Then we go through a rigorous internal review of your project. No project will be leaving and be submitted without internal review. And that has brought both the department and also my lab into having quite a success with the MSCA over the years. In the last years, we have applied 5 times and actually received the grant 4 times, and you can look them up on what was shown earlier, the Cordis website. It's EpiLiver, EpiTarget, Miracle, and EPIC. Currently, there are 2 people in my lab that have had MSCAs, individual MSCAs. They have finished them and are currently finishing off their projects. So there will be experience in the lab for you to develop your project also with people that have written these proposals. If you're not necessarily thinking of applying this year and moving to Copenhagen this year, I'm very happy to hear from you already now, because as was said earlier in the MSCA coordinator from Slovenia, it takes a long time actually to write this proposal. It might not seem like much, 10 pages, but to get the content of this down to 10 pages, it takes some time. So I'm very happy to hear from you if you're finishing your PhD, or if your PI is nudging you to or nudging you to leave your department and trying new areas, either in collaboration or with you just flying all by yourself to Copenhagen. Thank you very much.